we're going to continue the discussion about revealed preferences. I'm going to talk about its principles, and then I'm going to talk about three main types of revealed preference methods, or I think it's the only three: defensive, expenditure, travel cost, and hedonic pricing. I'm going to show some empirical examples, and I'm also going to go into some of the econometrics as we go along. This is where we are in the sequence. We're beginning to approach the end. Last week we talked about what is value, what do people historically think about value, and what is the aim and purpose of monetary valuation. And then this week and next week we're going to talk about how to do it. This week, as I said, revealed preferences. Next week, stated preferences. So that's where we are. Let's start with the principles behind revealed preference. Essentially what you do in these methods is that you infer the preferences of people for environmental goods by analyzing their behavior in real, related, or surrogate markets. So we're observing people, we're not making any judgments about them, we're just observing what they're doing, and we're observing them in real life. And that's the big difference with what we're going to do next week, where we're putting people in hypothetical situations. We're asking them what they would do. Here we are looking at what they do, or sometimes asking them what they do. There's three kinds of surrogate markets. First is where the market behavior, the observed behavior, is a substitute for the environment. So E stands for environment, M stands for market. And because we're looking at the market, we automatically have information given in money, that is in pounds sterling. And one example would be if you substitute fresh water that is just out there for bottled water, right? You no longer trust, you shouldn't trust just going into a stream and drinking water from it. That is highly inadvisable. Of course, that is what the people of old used to do, and that is what people in developing countries still do. You guys, assuming that you've grown up in England or in a European country, your stomachs are too weak for this, right? You should never drink unpurified water because you, from very young age on, you have been accustomed to purified water, treated water, and you should never ever do this. If from young age on you have been used to drinking contaminated water, your stomach is a lot tougher and you can get away with it, but then still you may prefer to go for bottled water instead because it tastes better, it may be healthier, a lot of the nasty elements, a lot of the risks are taken out. But here the idea is very simple. You substitute a marketed product for a product that comes for free, right? So that is one thing you can do, and this comes under the heading of defensive expenditure or averted behavior, where there's something bad in the environment and you make an effort or you spend money to avoid that badness or mitigate its implications, right? It can also be that the environment and the market are complements. So you derive utility from both the marketed goods and the environmental goods or service. And the example given here is that you're going to enjoy what looks like part of the Downs. But it could be other places as well. But in order to get there, you need to drive there. and you need to spend money on petrol. So here the environmental service, hiking in the hills, can only be enjoyed if you also spend money on travel, right? So now the environment and market are complements, and that comes under the heading of the travel cost method, right? And we'll talk at length about all three methods later in the lecture, right? The final option is that you purchase things as a bundle. The environment becomes an attribute of things you buy in the market. And I don't know why this picture appeared too soon, but if you buy a house, and this is a very peculiar looking house, I don't know where it is. George put these slides together. You do not just buy the house, but you buy the environment, the surroundings of the house as well, right? This famous television show, location, location, location. That is what drives, to a large degree, the housing market. And in this case, if you buy the house, you get the wheat field that comes with it. And if you're Theresa May, you'd like to run around wheat fields, right? And therefore, you may want to pay more for this house because you have a wheat field to run through. This group of methods is known as hedonic pricing. It is a very counterintuitive and peculiar way of calling things, but it's the way it is. The good thing about revealed preference methods is that we're looking at what people do. Next week we'll talk about stated preference methods, where we have the problem that we're looking at what people say they do, or what people would like to do, which is not the same as what people do, because they may not give you truthful information, right? People may simply lie to you in the survey. But also oftentimes people actually don't really know what they're doing. It's been shown time and time again in these sort of studies that people actually have a pretty vague idea of how they go about their lives. Another good thing about revealed preferences is that typically this is a fairly cheap way of estimating monetary values, where cheap means you can do this. It's going to cost a junior researcher a year or so. So that is the order of magnitude that we're talking about. It's somewhere in the range of 50 to 100,000 pounds to do this. And because we're looking at real behavior rather than hypothetical behavior, you don't need to put in as many safeguards. So it actually becomes all a lot simpler. And oftentimes, if we go back to hedonic pricing, for instance, if you look at the housing market, you don't need to collect data. You just need to convince real estate agents or one of the aggregator websites, like I want to say Zoom, but I need to say Zoopla, that actually collects all this data for you. Or in a place like England, the government actually provides, because every sale is reported, there's actually, you can just download all the prices that everybody's ever paid for their house, right? That's just on a website, and for the last 20 years or so, you can just download every transaction on the housing market in a country like the UK. So the data is just there at your disposal, right? So that makes this study just a whole lot simpler. The weaknesses of revealed preferences is, first, it's real behavior. So we can only look at real things, and that typically restricts the attention to use values. It can have a little bit of option values sometimes, but definitely non-use values do not show up in these sort of studies. What you do in a revealed preference study is you infer people's preferences from their behavior. But that inference makes all sorts of assumptions about how the market is structured, and also makes assumptions about the rationality of people. So you can only go from, I can only go from what you buy in the supermarket to what you would have liked to purchase in the supermarket, your preferences, by assuming that you were completely with it when you went to the supermarket, and that the supermarket indeed provides for your needs, that there's no market power pumping up prices, or that there's no rationing withholding certain options from you, right? I need to make those assumptions about how the market functions if I want to go from what I observe you do to your utility function. And another problem is, of course, that prices reveal preferences, and preferences reveal utility at the margin. And if you're looking at large-scale chains, then essentially those marginal values may not be that informative, because it's not just that our utility is at the margin then, but also the implication is that we can only really use this to value small changes in the environment rather than big changes in the environment. Good things, bad things about revealed preferences, right? So next week we'll talk about stated preferences, where some of these things are actually reversed. That some of the good things about revealed preferences you can't do with stated preferences, but on the other hand, some of the drawbacks of revealed preferences can be taken away with stated preferences. So let's look at defensive expenditure, and what you're looking at here is a cyclist who has two investments in his safety. One, he is wearing a helmet, and that is a substitute for road safety, right? If this were a completely safe road, perfectly paved with no annoying cars on the road, then less reason to wear a helmet, and if it's flat you would have no reason to wear a helmet. But he also has this thing in his mouth that the pictures suggest, of course he may also just be measuring his breathing, but the pictures suggest and the context suggests that this is to filter out air pollutants, and he breathes cleaner air than he otherwise would have. And of course this is a substitute for clean air, right? If he were to cycle through a pristine environment, he would not have needed the air filter in his mouth, right? So that is what defensive expenditure averted behavior is about. So, what would you do? You would essentially look at people's expenditure on such things as bottled water. Presumably that mitigates the risk of illness. You would look at expenditure on double glazing, which would reduce noise in the house. You would look at expenditures on cycle helmets to mitigate the risk of injury and death. And actually in the seminar we talked about cycle helmets and things. And that is essentially what you do, right? It's as simple as that. But of course, the principle is simple, but it does not mean that the practice is simple, right? And I'm going to go into some of these examples later, but one of them is, here says that you spend double glazing to mitigate noise. And if it is true that you find somebody who's invested their money, some of their money in double glazing to prevent noise, then you have a clean measure. But it may also be that they have double glazing to reduce the energy use of their house, or they may have done it for both reasons. Or it may of course be that somebody came along and installed double glazing without asking them, right? That the window broke and windows were replaced and they did not pay attention when they ordered this and got double glazing, right? And of course nowadays newer houses come standard with double glazing. So it's easy in principle, but it requires a bit of thinking in practice. I'm going to look at one particular case study which highlights some of these issues. And we're going to look at giardia in water, and this is the bacterium, and this is one of those things why you should not drink raw water, because if you're not used to this, it'll make you very, very ill, very, very ill, right? So the case study is in Milesburg, which is in Pennsylvania. It's a pretty small one. It's an older study by Laughlin, published in 1993. Giardia causes severe diarrhea, not just diarrhea, fever, cramps, nausea. It really, really makes you ill, and it's intestinal parasite. So what happens, as so often, was that the water treatment company did mess up, and unfortunately there was giardia in the tap water, right, in Milesburg, Pennsylvania. So you can ask, so what is the welfare implication of this? You can also ask the reverse question, so what did people do to avoid falling ill? What effort did they go through? And they did all sorts of things. Some people switched to bottled water, and you see an example here. This was 1989, right? So that explains this, and this really is the United States. 30 years ago. So you can switch to bottled water. It is a nice alternative. It is more expensive. You can also say, well, it actually created employment for this guy on the motorcycle here. You can put in water filters. You can boil your water. So it's a biological contaminant. So if you boil it, it is dead, right? Very few organisms survive boiling. Actually, I think it's true that no organism survives boiling. So that is all sorts of things that you can do, right? It costs money, it costs time, it costs energy. The big issue in this particular study is the time that people spend and how you value that time. That was the big uncertainty in this issue, in this study, because you can just look up what is the price of bottled water versus the price of tap water, right? That's a very simple comparison. How much energy do you spend? How much gas? This is a gas stove. How much gas do you need to boil a liter of water? That is just something that you can look up in an engineering textbook, right? So that is not difficult, but the time aspect is actually the one where the uncertainty comes in. And that is what you see in the results here. The total expenditure, if you include time, or if you exclude time, was $8,000 for the 500 or so households. So this is a smallest thing, right? It's not that they spend 8,000 per household, but they spend 8,000 for 500 households. If you value their time, so this is if you ignore time, it's 8,000. If you value their time at the minimum wage, assuming that most of the stuff that you do, like boiling water, is essentially unskilled labor, then the total cost goes up to 18,000. You say, oh, yeah, it may be unskilled labor, but somebody has to do it, and that somebody may not be unskilled, right? We actually should be looking at the opportunity cost of time rather than the replacement cost. If you would hire somebody in the market to do this for you, which of course doesn't work, right? Because there are no people around to do this for you, because it's a thing that just happens incidentally. So it's not that in Millsburg there were a couple of unemployed people hanging around waiting to boil your water for you. Of course, you would not really want to invite them into your house to boil water for you and then kick them out after they've done that 5 minutes, right? That's not sort of market transaction that you could expect. So really we should not be looking at the replacement value of our time, but we should be looking at the opportunity cost of our time. It's people like me that are doing the boiling of the water rather than preparing for lectures. If you then take the midpoint of the wage of the people in Millsburg, the value actually goes up to 45,000, right? So the crucial parameter in this study is time and the value of time. And you see that it makes a big difference, right? If you ignore time, it's 8,000. If you look at the opportunity cost of time at the midpoint, at the median, then it's 45,000, right? And that's a big difference. So this sort of seems simple, right? But if you then bring it to an actual case, it's actually pretty hairy, and you need to make assumptions that are not necessarily credible. There's other problems with this approach. Mitigation is generally incomplete, right? Double glazing helps against noise if you're in the house, but you may also want to spend time in your garden. Or in summertime you may want to open your windows, and then double glazing really doesn't help. You measure the minimum willingness to pay, right? Yeah, people may have been prepared to pay more, right? So you observe 1 point of the you observe the demand function where it hits the supply function, right? So that is what you observe, but you don't observe the rest of the demand function, right? And you need to make assumptions about how steeply the demand function slopes, because bottled water is supplied in a competitive market. So you don't observe how much people would have paid for it, because they pay what they pay in the supermarket, right? And you only ever observe where the supply curve hits the demand curve, and that doesn't tell you a whole lot about the rest of the demand curve. Defensive behavior actually comes in all sorts of flavors, and it is sometimes hard to find all of them, right? So some people would have boiled their water and filtered it anyway, or filtered it first and then boiled it, right? And occasionally switch to bottled water. So there's a mixture of things. And of course it may be that some people moved away from water altogether and switched to beer or wine or what have you, right? So there's all sorts of things going on, and your typical household would have done a range of these things, right? And there's a portfolio of measures against this. So one alternative that you could do, if you say, well, I can't trust the water, is of course you can change your behavior so that you sweat less, so that you need to drink less water, and you could opt for less exercise, and then including that in the portfolio of responses, it becomes you need to start collecting a lot of data about these people, right? Not just did they buy bottled water, did they boil their water? No, but did they respond in other ways as well? You need actually to observe a lot of things. Same is true for air pollution. It's not just the filters and stuff, but also people staying indoors more. And what we've seen in India at the moment, right, that the averted behavior for the air pollution, very heavy air pollution that you see at the end of summer in India, because all the farmers are burning their fields, their crop remains, is that they close the schools, right? At the moment all the schools in India are closed because air pollution is so bad, or in North India all the schools are closed because air pollution is so bad. That is averted behavior, right? And quantifying that and quantifying the long-term economic implications of less schooling by a week is actually becomes pretty difficult, right? So simple in principle, hard in practice. There's the joint products that I talked about already. People may also switch to bottled water, not because it's healthier, but because they think it tastes better, and that of course also depends on the tap water that you get. So let's turn to the second group of methods, and that is the travel cost, where the market is a complement for the environment, right? In defensive expenditure it's a substitute, now it's a complement. And the travel cost method, as you may have guessed, is often used in tourism and recreation. Tourism pictures at the top and to the left, recreation more to the bottom and the right. The difference between tourism and recreation is that the tourism you stay overnight, right? The travel cost method goes back to the guy you see here, Harold Hotelling, who you do not know. So Hotelling has the very unfortunate legacy that he came up with the definitive proof of the first and the second welfare theorem, that you guys call the first and second welfare theorem rather than the first and second theorem of Hotelling, right? Irony has that he is also famous for the Hotelling rule, which actually it was Faustman who came up with that rule. So he's famous for something that he didn't do, but not famous for something that he did do. And then the travel cost method is of course known as the travel cost method rather than the Hotelling method. And he did it in this letter, dated June 18, 1947. And let's zoom in. Let concentric zones be defined around each park so that the cost of travel to the park from all points in one of these zones is approximately constant. The persons entering the park in a year, or a suitably chosen sample of them, are to be listed according to the zone from which they came. The fact that they come means that the service of the park is at least worth the cost, and this cost can probably be estimated with fair accuracy. If you assume that the benefits are the same no matter what the distance we have, for those living near the park, and consumer surplus consisting of the difference in transportation costs, and then his grammar is wrong again. The comparison of the cost to coming from a zone with the number of people who do come from it, together with a count of the population of the zone, enables us to plot 1 point for each zone on the demand curve for the service of the park. By a judicious process of fitting it should be possible to get a good enough approximation of this demand curve to provide through integration a measure of the consumer surplus resulting from the availability of the park. It is this consumer surplus calculated by the above process with deduction for the cost of operating the park, which measures the benefits to the public in that particular year. So there you have it. This is the travel cost method, and hoteling not only gives you the principle but also how to do it. So essentially, if you go to the cinema, you pay an entrance fee, and that entrance fee tells you your willingness to pay to see this movie, if that is your intention in the cinema, right? And at least in anticipation, you think that the £5 for students that you pay to get into the cinema is worth at least as much as the enjoyment of seeing this movie, right? Otherwise, you should not go. Of course, it may be that the film disappoints, right? But but at least in expectation, you think that watching this movie is worth at least £5 to you. If you go to Stenmer Park or Preston Park, Stenmer Park is just here, or Preston Park in Hove, then you do not pay an entrance fee, because it's a public park, anybody can walk in. But you do, because if you go to Preston Park, presumably you guys don't live in Hove, you need to take the bus to get there, right? So you may pay £1.80 in bus fare, and you may spend 20 minutes to get there. So you do pay an entrance fee. It's just not that you pay it when you enter the park, but you pay it in getting there, right? So that is the principle behind the travel cost method, that you look at travel behavior, travel expenditure, time and money to get there. And then what you do, as hoteling suggests, is that you collect data about the people who go there. How did they get there? How much money did they spend? How much time did they spend? And from that you derive a demand function, and then you integrate under that demand function. Right? That's the principle. And again, it sounds trivial and intuitive, right? Can be applied to all sorts of things. Opening and closure of sites, that's what hoteling was talking about. Changes in the quality of the site, and also changes in the access cost to the site. And you can do this in two ways. Hoteling suggested a zonal method, but you can also look at individual. I'm going to talk about two. And I'm going to talk about both of them, sorry. And you can do this for single sites, but you can also do it for multiple sites, where the single site has an immediate problem, right? I talked about Stenmer Park and about Preston Park. They compete with each other, right? So I can collect data about visits to Stenmer Park, but I would get a strange estimate if I do not consider the fact that you could also have gone to Preston Park, right? And that if it turns out that there's a big drugs problem in Preston Park, I don't know. There's a big drugs problem in other parks in Brighton that I do know. If that problem is there, then that actually drives people towards Stenmer Park. It's the, what it's called now, where all the fountains are, and that is a big drugs problem in central Brighton, like near the Pavilion. And that may drive young families to go to Stenmer Park instead. But of course what you're measuring there is not a preference for Stenmer Park, but an aversion to the levels. That's what it's called, right? And you need to be careful there. You need to look at the alternatives as well, and then you need to be use random utility models instead, which is just a variant conceptually on the travel cost method. So how does this work in theory? We have a yes, it works. We have an economic agent who wants to maximize her utility, that's the U, by choosing visits to a recreational site and spending time on that, right? It's also a choice variable for some reason. And utility depends on some composite good X, as well as, if I look here, it feels better. So the utility depends on composite consumption X, as well as your recreational activity. And this is a slightly different problem than what you're used to, because we have a money budget. This is what you know. So this is your expenditure per visit, and this is your expenditure on other consumption. And that, of course, you cannot spend more money than you have. So this is the total time that you have, and this is the total time that you work, and this is the wage that you earn, right? And then the problem is different than what you're used to, because we also have a time budget. And the assumption here is that you can do two things. You can either go to the park or you can work, right? Those are the only two things that are available to you, and there's nothing else you can do. Very boring life. And of course, those two need to add up. Now, you haven't seen a problem like this in micro, but we can rewrite the problem. Does this work? No. Things should appear one by one. But they don't. They appear all together. And disappear altogether. Get out of here, you. So we can actually rewrite this into a standard problem as follows. So this is our yes. So this is our money budget, right? And the second one is our time budget. Then the price for recreation per trip is really the time of travel, or the cost of travel, C, plus the time spent traveling, TR, times the opportunity cost, W, right? That is the entrance fee that we pay. Now, if this is true, then we can multiply both sides of the equation by R and bring the WTR to the other side of the equation to have this expression here, right? Simple algebra so far. So now we have an expression for CR. So this is the second budget constraint. This is the price. This is the second budget constraint rewritten. Now we can substitute this solution here into the first budget constraint to find this expression, right? It's simply the same, but with CR replaced. We can bring WRT to the other side of the equation and get W outside the brackets to find this expression, still the first constraint. Now, this thing that we have here between the brackets, TW plus R TR, that's our time constraint, right? So we can replace this by T. And what we have done now is combine the two constraints, the time constraint and the budget constraint, into a single constraint. And now we know how to solve this. We want to maximize this by choosing R, and this is our budget constraint that now combines time and money, and simply derive the first order conditions. So by the assumption that we make here, that we can substitute time and money through the opportunity cost of time, and we are price takers. The W is outside of our control. We get paid the weight that is dictated to us by the market. Recreation becomes a standard consumer good, right? And the key assumption here is that time is money. And that you can choose freely to work an additional minute and get paid an additional minute, right? If you're prepared to make those assumptions, then you can treat recreation as a standard consumer good. And then what you do is you have a demand function for the recreational side and for the number of trips, and you can simply integrate under that demand function to find the consumer surplus. So the way this works in practice is, as our telling suggested, you have a site of interest, let's call it Stenmer Park, and you collect, and obviously nobody lives in Stenmer Park because it's a park, right? And you draw circles around this park, and you say, well, the people who live in zone 1 need 5 minutes to get to the park, and the people who live in zone 2 need some 15 minutes to get there, and the people in zone 3 need half an hour to get there, right? That is, and then of course, if you take into account roads and buses and everything, these would not be concentric circles, right? That's only in textbook examples that these are concentric circles. And then you collect data about them. Now this example is not about Stenmer Park, as you may have guessed from the numbers, right? So let's assume that from zone 1, 15,000 people visit per year, from zone 2, 48,000, from zone 3, 11,000, and so on and so forth. But that doesn't mean anything. You also need to know the population, the people who potentially could have visited, right? So in zone 1, 2 million people live, and in zone 2, 8 million people live. So we're no longer talking about Stenmer Park, right? And so on and so forth. And then you also have a travel cost, and that just goes up by £5 per zone. So £10 for the first, 15 for the second zone, and so on and so forth. So that is the data that you need, right, to make this work. Then you calculate the visit rate, that is the fraction of people from the zone that visited the place, so that's V over N. And then you can fit a demand curve, right, where essentially you say, and the example here is to use ordinary least squares, where you derive a relationship between your visit rate and the cost, right? So what you would do is divide this number by this number, and then run a regression of the result on this number. That is your explanatory variable. That's your independent variable, and your visit rate is your dependent variable, right? So you explain the visit rate by the travel cost, and in this example, this is what you would find. And then you can play around. What you could do is you could say, well, what happens if instead of free parking, you need to pay £5 to park your car, assuming that everybody comes by car, which, given the distances that we're talking about, seems a reasonable assumption. Right? Price goes up, then with the model that you have, you can also predict what would be the new number of visitors, right? Costs have gone up, so zone 1 has become like zone 2, and zone 2 has become like zone 3. So we have a new R, and therefore a new number of predicted visitors, and from zone 1 the number of visits falls from 15 to 12,000. So now we have a change in the consumer surplus, associated with, in this hypothetical example, charging for parking in this particular place, right? So that is how it works in practice, the zonal travel cost model. So there we have a demand curve, and there we have a consumer surplus, and that's it, right? So, very simple example. You can do all sorts of better stuff. I assume the linear relationship. Who says the relationship is linear? I used OLS to estimate it, but of course we have sensor data, so you should use Tobit. I forgot to say a few things. Can do better than this, right? What you could also do, instead of a zonal travel cost method, where you put everybody in a zone and you assume that they are all the same, you can estimate individual travel cost methods, where you treat people, everybody has their own zone, essentially. This is much more demanding on your data needs, because rather than saying all you guys live somewhere in central Brighton, so all you guys need 15 minutes to get to 20 minutes to get to Preston Park and 15 minutes to get to Stenmer Park, I could ask each of you individually where you live, right? It would be totally inappropriate for me to ask, and sort out exactly how much time you would need, and also interview you about your preferred mode of travel. Do you take the bus? Do you go walking? Do you go cycling? Right? That would give a much more precise estimate, but of course I need a lot of additional data. There's two ways of doing this. Either you can ask people, how much time did you travel? How much time did you need to get here? Or you could just ask a simple question, where do you live? And then use a GIS, a geographic information system, coupled with a travel model to actually sort out how much time you needed to get there, right? As soon as you have individual level data, it's no longer everybody lives in a zone and you're sort of half male, half female, right, roughly. You can actually have gender in there, and age, and income, and what have you, and you have a much richer specification, right? And you can look at, is it particularly rich people that travel to this park, or is it particularly people with kids that go to this park, right? That the environmental service is for a particular segment of the potential market. I talked about this already, that a proper demand curve also includes the substitutes. That it doesn't make any sense to look at the value of Stenmer Park or Preston Park without looking at the supply of all parks in the Brighton area, because people can choose between them, and it's not always pool values. It's not always pull factors that get you there, but as I said, with the drugs problem in the levels, it may also be push factors that get people there. And of course, if you look at a single park, you cannot learn a whole lot about the attributes of that park, because they're constant. And definitely if you have a short-term survey, you just collect data of what happened in the summer of 2021, and Stenmer Park is as it is. And what you see is a total value of Stenmer Park, but not whether people, it's like the trees that are there, or the hills that you can see, or the fact that there's a soccer pitch, all those things, a football pitch, we're in England, all those things sort of wash away because they're constant, right? So if you want to see what do people actually like about a park, you need to have multiple parks that are different from one each other, right? Can we actually do this? Yes, we can. For that you need random utility models. These are different colored iPads, right? iPods, whatever. And there you can deal with those issues of site quality and competition between sites. You cannot do the other things. So what you do is that you observe that individual I chooses to go to site G. That is what you observe, right? And we have a number of G's and we have a number of I's, right? We have a number of sites and we have a number of individuals. So what you can deduce from that I observe Jurgis going to Preston Park, is that Jurgis on that day preferred to go to Preston Park rather than to Stanmore Park, right? That is the information that I have. So the utility for Jurgis on that day of being in Preston Park outweighed the utility of going to Stanmore Park. That is the only thing I know, right? Assuming that he's a smart guy, which is a big fair assumption, right? So that is what we know. That is what we assume, that people behave rationally, right? Now, may have had all sorts of reasons to do this. So what we want to do is sort of have a deterministic part, and we call that V, structural reasons why people are in Preston Park rather than in Stanmore Park. But tastes vary, people may have different preferences for things, circumstances may vary. So we also have a stochastic or an idiosyncratic part, and we call that epsilon. So really what we have observed is that the deterministic part plus the stochastic part, V plus epsilon, for individual I in park G, in sites G, is greater than being in park J, right? So this is just replacing utility by its two components, a deterministic part and a idiosyncratic part. Then we can say, well, that structural part can be a function of income, it can be a function of travel cost, and importantly, it can be a function of site quality. So V okay, that's what I don't know why. Oh, I do know why. If you think back to me making recreation as standard goods, is that we have this perfect fungibility of income and expenditure, right? So that implies that the coefficient on income and travel costs should be the same, right? That is the implication of making recreation a standard good. So the V becomes a linear function of income minus travel cost and site quality, right? Then we assume that the error term is a Gumbel distribution, and you may wonder why do we assume this? I never heard of a Gumbel distribution. This is what a Gumbel distribution looks like. It's not a bell curve, right? What you see is that it has a strange shape. It is left skewed. That is, the left tail is heavier than the right tail. I may wonder, why would you assume this? Well, the answer is then the math is easy, right? And if you make that assumption, then you can actually work with this model, and it becomes a conditional logit, and you don't need to know why. And essentially what this conditional logit then predicts is the probability of individual I being in site G, right? Out of all the parks J that we could have chosen, and therefore you need to sum that probability, this is where we are. So we get a relative probability. This is the chance of us observing jerkers in Preston Park, right? I actually don't know, because I never go to Preston Park and I've never seen jerkers there because I never go there, right? That is for that particular individual on that particular site. Then of course we multiply the probabilities for all our observations, or rather we take the log and add them. We have assumed that V is a linear function of our observables axis, and then we use maximum likelihood to find our betas, right? So that is what you do. And then you have visits as a function of all your observable characteristics. Income, travel cost, quality of the site, are there drug users there, are there mums with prams there, all those things you can stick in there, and then you can play around with your quality and say, well, what if there was a nice pavilion in Stenmer Park? Would it attract more people? Or a bandstand, would it attract more people, or would that deter people? And therefore, would it be a good idea to build this thing, right? In principle, then you can also have investigate scenarios where you add a park. Of course, we're not adding a park, we're adding a bundle of characteristics. That the new park is a combination of the characteristics of the new park are a combination of the characteristics of the existing parks. And you can investigate the implications of that, and you can of course also investigate the implications of removing a park altogether. Number of assumptions that you make here. What we don't explain is how often you go to the park. And that may need to be modeled separately. What is not in here is actually a love of variety. One day you want to go to one, and you may always prefer to go to Preston Park, but at a certain point you think, well, Preston Park looks remarkably like it did last week. Let's try something different. That is not included in here. What you do need to assume is independence of irrelevant alternatives, and of course now I'm no longer talking about Preston and Stenmer. I should have prepared better. Now I'm talking about Wakehurst and Sheffield Park. It's a slightly further afield. That the assumption of independence of irrelevant alternatives that is baked into this conditional logic stuff is that whether you choose to go to Stenmer or Preston is independent of the the relative probability of going to Preston rather than Stenmer is independent of whether or not you know about the levels, right? That is the assumption of independence of irrelevant alternatives, which is probably a realistic assumption in this case, but it's not always a realistic assumption, right? But that is baked into this. So let's look at half an hour left. Let's look at some one application, and we're going to South Africa, more specifically KwaZulu-Natal, to look at lions. This was a study that was done, published by Day et al. In 2002. And they looked at 4 alternative parks, and I'm not going to try and pronounce the names. There's actually loads of them around here. And because the whole point of game parks is to look at game, and these are smart animals, so they're active at dawn and dusk when you can see things, but it's not too hot, right? That is why they do that. And they're pretty far away from where people live, so you really need to spend the night there, right? It's just not a day trip. And there's various types of accommodation. So the question here is, what are these parks worth? And what can explain that difference in worth? Has that to do with the management of those parks? And of course, for the managers of the park, the question is also, what is my demand curve, and can I put up my prices without losing too many customers? And there's two components to this pricing. One, how much does the hotel cost locally, or a tent? How much do you pay in accommodation? And there's also an entrance fee to the park. You can't just wander in. These are private. So what you need to do is identify the choice set. And we're in KwaZulu-Natal, so people speak click languages there. So I'm not going to pronounce these names because I would completely mess it up. And there's a difference in the quality, right? There's a difference. In one place you have a luxury hotel, and the other place you need to stay in a tent. In some places you can see lions and elephants and rhino. In other places there's only the elephants, right? The choice set, or the agents here, are all locals from South Africa. You could have expanded the market to international, but these are the sort of the smaller parks where it's mostly locals who go there. So what you need to do is, first you need to collect data on the visits. You could have used the administrative data, then you would have 26,000 observations. But you also want to know a little bit about these people, so you need to interview them, and they took a sample of 1,000, right? Only. The individual data is, where do people live, with whom did they travel. So I talked about travel costs as something abstract, right? Your time spent on the bus and the money you spent on the bus. That's not how travel works, right? And definitely not if you go to someplace nice. You actually may go with your friends. And actually the trip may actually be an enjoyable part of that if you have nice friends. Or you may go with somebody who annoys the hell out of you, and then actually there's an additional cost to travel, right? Or you may end up in a train full of football supporters. And then the trip may be less of a pleasure and may actually have a higher cost, right? So the party size is actually important. The type of accommodation, how long they stayed, which part they visited, how much they paid in entry fee, and how much they paid for the accommodation. Then from where they lived to where they were, you need to sort out how did they get there. You would have to assume that actually they started from where they live, right? They may have been visiting family and started from a place that was not home, right? And then you can also tie it up with neighborhood socioeconomic data. Use the GIS system to calculate door-to-gate road distances, making the assumption that people travel by car. And of course you don't know what car they took, so you're sort of guessing how much they spent in fuel, and so on and so forth, right? You see where this is getting. Again, it sounds so very simple in theory, but if you're actually going and collecting this data, then it becomes much more difficult and much more uncertain. And again, you need to assume wages. Wages were not observed in this study, but rather we know where they're from and we know the average income of the people in that area. So let's assume that the people who visited us had that average income, right? If you make all these assumptions, then you can calculate the demand curve, and you can indeed calculate the consumer surplus. And here you see the numbers. And they're actually considerable, right? Starting from 20, 18, 19 dollars per trip per person. Well, that's reasonable. Recall that this is South Africa and this is South African incomes, right? Up to 50. So people are prepared, obviously, to pay over what they really paid, right? So this is the welfare gain from just visiting the park. So, final technique is hedonic pricing. And the house that you're looking at is in Dorchester. Now, if you buy a house, as I said in the beginning, you do not just buy the house, but you buy its environments as well. So, if you are, you guys are not on the market for this house here, you do not just get that it has 4 bedrooms and 3 bathrooms, and that it was built in the 1700s, I'm guessing, and has a very low energy rating. That is not just what you buy, but you also buy the fact that the house sits on this canal, which you may think is a good thing, right, because you like looking at water. But you also buy the fact that canal in summertime is a breeding ground for mosquitoes, and you may not like that. And that on the other side here there is a there's a little footpath where there's loads and loads and loads and loads and loads of tourists that walk by your house all the time, right? That is not in your house, right? But you can't separate the house from its surroundings, right? So it's, and that it includes environmental characteristics, such as aircraft noise, which is not an issue in Dorchester, and the water and the green spaces, but also have to do with the quality of the local schools, right? And the crime rates in the area, and the labor market near you, and so on and so forth, right? All those things you buy as a bundle when you buy this particular house. So what you do is, again, you define a function that has a idiosyncratic component, an error term, an epsilon, and now we can actually use OLS. So this is normally distributed rather than a Gumbel distribution. And we have a function of all the characteristics of this house and its environment. And that is what we want to estimate. And then, if one of these Q's, if one of these attributes is green spaces or proximity to water, then you can play around with this, right? And say, what if this house were further removed from water? What would the drop in value be, assuming that people value proximity to water positively? And you can go to Rightmove, right? Earlier I talked about Zoopla. Rightmove is another option where you can just look at the price. Not if you go to Rightmove, right? At Rightmove, what you would find is the asking price, not what people eventually pay for it, right? So that is difficult. In the register of house sales, you can actually find the price that people paid. Problem is that that does not have all these characteristics. If you go to Rightmove, you can actually, they list, because they want to sell the house, they list all the characteristics of the house up to the color of the bathroom, right? Which doesn't matter because you can just repaint it. So, and then you can also know the exact location, so you can tie it to noise and air quality, water quality, scenic views, and so on and so forth. You have all the structural characteristics of the house, floor area, number of rooms, number of bathrooms, and so on and so forth. Rightmove would actually tell you distance to the closest bus stop, distance to the closest train station, also distance to the closest school, and the Ofsted rating of that school, right? All those things Rightmove will tell you. It won't give you the crime rates, but you can look that up. You can use the census to look at the average age of your prospective neighbors, and so on and so forth. And all these data are there, and of course all these things are important. Then you can tie this up with GIS data. And what you're looking at here on the left is noise. So this is traffic noise in Greater London. And this is, lo and behold, Heathrow, right? The noise that comes from Heathrow. This is air quality. I think it's PM10, so very small particles of pollutants. And you can see the road network actually there. This is generated by traffic. And then as you go further out, air quality actually improves. In the inner city, air quality is generally bad. And this is not a Pollock painting, but this is the types of land that you have. Where in blue, you need to look very closely. You see the Thames and some of the lakes, reservoirs in the north. In black, you're looking at residential areas. In red, you're looking at industrial areas, and then in green, you're looking at open space, which can be parks, but it can also be agricultural. No, in green you're looking at parks, and in gray you're looking at agricultural land. Right? So you can also calculate your distance to any of these things. Stick that in and estimate the whole thing. And then you have an implicit price, right? So one example, I think this is London. For every 100 meters that a house is further away from a subway from an underground station, why do I keep switching back to America? Every 100 meters you move away from an underground station, the price of the house falls by £10,000. Right? That is roughly the relationship you would find in London. So you can value access to public transport in that way, right? Similarly, if you can see a tree from your bedroom window, then the price of the house goes up by a few £1,000s. Right? Those are the sort of things that you find, and then you can derive these values. It's easy to just look at the marginal substitution. If you want to complete demand function, you need to work a little bit harder. And here is an example. And it only says it's from the US. This is a big place, right? And you find all sorts of characteristics, right? Obviously, the age of the house matters. Older houses are worth less, bigger houses are worth more, houses with more bathrooms are worth more, houses with a pool, must be in California or something, are worth more, and so on and so forth, right? Houses with a lot of crime in the neighborhood are worth less. Houses with a lot of whites in the neighborhood are worth more, right? We are in the US, and we're gonna next week. No, the week after next, we're actually going to talk about environmental justice. Whenever you run these regressions in the United States, race always pops up, right? Because there's a lot of racism in the US. These characteristics do not pop up in European regressions because we don't often measure ethnicity, not because it doesn't matter, right? Because we close our eyes to this. But in the US, it always pops up. Housing density, and then here what we are talking about, if there is a lot of total suspended particles, TSP, air quality is bad, the price of the house goes down, and it does so significantly. If there is a lot of NO2, then the price of the house goes down as well. This is another indication of air quality. So these things matter, and these regressions work, right? Now, there's all sorts of assumptions that you're making here. You assume that people actually know what they're buying. As soon as you stick one of these regressors into into your equation, right, then you assume that, yeah, the buyers must know about this. And whereas the number of bedrooms is easily observable in a house, its air quality, it's not necessarily something people know about, right? And there's actually been a couple of studies where they show that these things start to matter as soon as information is given. And one of the things that was done in England and Wales a few years ago is that when you buy a house, the seller, or rather the real estate agent, needs to tell you about the flood risk of that house. 10 years ago that was not the case. Today it is the case. So 10 years ago, running a regression of house price on flood risk would not have made any sense, and indeed it showed insignificant results. Now it actually does matter, because people study flood, or at least some people study the flood risk before they decide to buy the house, right? So nowadays flood risk matters. It used not to matter in these regressions. So information is important. We assume that these markets are working fairly well and are also in an immediate equilibration of the markets. And because of that assumption, the only thing that you would find in an hedonic house price regression are the characteristics of the building and its environment. You never find the characteristics of the buyer or the seller, right? And you may think that that is strange at first sight, because richer people would buy different houses than poorer people, so that should matter. But because we assume that the market is in equilibrium, that should not matter, right? So we live in a house that is near an excellent primary school. And because of that, the house that we have is maybe £100,000 more expensive than a house that sits near a bad primary school. And that makes sense, right? Because we have one kid still that is going to primary school, so we are willing and able to pay more for the house, right? But when my son goes to secondary in September next year, it's not that the price of the house is going to fall, right? Because we no longer care about the quality of the primary school. The individual characteristics of my family will change structurally in September, as we no longer care about primary schools. But the resale value hasn't changed, because there's other families with primary school going children that would like to buy our house, right? Because it sits near an excellent school. So the individual characteristics do not matter, right? It matters for our decisions and for where we live, but it doesn't matter for the price of the house, right? Because we have lost interest in the primary school, but the potential buyers have not, right? So the price of our house does not drop if my son moves to secondary. Clear? Yeah. So that is why there is no characteristics of the buyer. Another assumption that you need to make in hedonic pricing is, of course, is this a linear function, is it a multiplicative function, and so on and so forth, right? Where are we for time? 10 minutes left. Good things about hedonic pricing is there's lots and lots of data available. Property markets respond to these signals. Weaknesses are the assumptions that you need to make, the information that is available, and so on and so forth. The biggest disadvantage that I haven't talked about is that markets are coupled. So the environmental quality does not just affect the house price, but it also affects wages. And what you find is that it's not so much that people are prepared to accept a lower wage if they work in a nice environment, but it is the case that people demand compensation in their wages if they are forced to work in not so nice environments. So you guys will be on the job market relatively soon. If somebody offers you a job in Paris, you think, yay, I'm gonna go to Paris, right? If somebody offers you a job in Murmansk, you think probably words that I'm not allowed to say, right? And you would immediately ask the question, so how much extra do I get paid if I accept this job in Murmansk rather than in Paris? Because Murmansk is a pretty desolate place with a terrible climate, and there's nothing to do there except drink vodka and play chess, right? That's the sort of things that people do in Murmansk. And of course it's dark 6 months of the year, right? No sun at all. Now, so you can also run these hedonic regressions on wages, and people have done that, and you would find indeed that environmental characteristics bump up there too. The problem that you have is that your housing market is closely tied to your wage, to your labor market. That in places where people earn a lot, house prices are higher, and vice versa, that in places where house prices are higher, people demand a higher wage. So if both are influenced by the environment, but you study just one, then you have a problem and your estimates are biased, right? So really you should run a regression on both houses, on both house prices and wages, as well as the interaction between the labor market and the housing market. And then it gets econometrically complicated, and I won't bore you with that, I'm just warning you. So, third case study, and that's the amenity value of English nature. So this was done by Gibbons, Steve, of UCL in 2011, and it fed directly into government decision making through the National Ecosystem Assessments. And they looked at all sorts of stuff: visual amenities, sports, cultural heritage, health, leisure, education, and so forth, as well as inspiration. No, I should press here. They looked at 1 million house sales, and they actually used data not from Zoopla or Rightmove or from the cadastre, but they looked at mortgage data. And of course the banks also know this, right? Because they won't give you a mortgage unless they know exactly what sort of house you're buying, right? So that is the data that they used from 1996 to 2008. So the house characteristics, neighborhood characteristics, and environmental variables. And what they were particularly interested in was the value of habitat. And here you're looking at a map of the United Kingdom. And we see all sorts of things. So this is partly administrative data where farmers report what they do, and we have, of course, data on all industrial areas because you need a license to build things, and you can actually by satellite also see a lot of things. So the blue bits are water. The brown bits that you see here are all sorts of arable lands, cereals, horticulture, and so on and so forth. There's actually different shades of brown here. There is the Scottish Highlands, and so on and so forth, right? And the green is mostly grass. And then the question is, I'll wait and there's more information. They had a location of the national parks. The South Downs National Park is here as well, right? It of course was there at the end of their sample, but not at the beginning. It's a fairly new one. They have the green belts, and then they have the National Trust areas, which are, in most cases in England, they're actually pretty small. That is why they show up. There's just lots of small National Trust areas. And then they ran the regression and found these as implicit prices. So proximity to, no, that's not how they did it. If in a circle around your house, but it doesn't say, oh wait, it does say in the notes. If within 1 kilometer square of your house, how strange, there is 1% more fresh water, then the price of your house goes up by £750. If the broad-leafed area goes up, then it increases by 400. Farmland, it increases by 100. So all these things are good, but people would rather live next to a forest than to a farm, right? Is what you see here. And lo and behold, what really matters to people is domestic gardens, right? That is what people like because they're nice and tidy. And of course, domestic gardens also signals that you live in a middle class area, right? That your neighbors are not crooks, but they are the sort of people who mow their lawn and tend their flowers, right? So it doesn't just signal environmental quality, but it also tells you something about your neighbors, right? That they're not unruly students. Best thing for the value of your house is to be in a national park. So if you can lobby the government to designate your area to be a national park, that means that your the value of your property has gone up. Similarly, being in the green belt also raises the price of the house. But being closer to a national trust property actually reduces the value of your property. And the reason for this is probably because National Trust attracts loads of visitors who then block the streets with their parking, with their badly parked cars, and so on and so forth, right? And we've seen that in a number of these studies that, yeah, it's nice to be close to the beach. It's not nice to be close to the place where people who go to the beach park their cars, right? And there's actually a trade-off there. It's good to be close to the beach, but not close to the tourists. And for some reason, Scotland and Wales and Northern Ireland have disappeared from this market, from this map. I don't know why. But this is then the total environmental amenity value, where the green, use my own mouse, the green is where we are, right? This is where the environment is nice and people and houses are therefore more expensive. Sort of did this, I'm not very good in English geography, I believe. This is the Midlands, right? This is sort of the worst place to be from an environmental perspective. This is where values are really, really suppressed. So this is the industrial area between London and Birmingham and Leicester, right? And somewhere near Northampton is the worst place to be. There's nobody from Northampton here that I've just insulted. No. No surprises here, right? For anybody who knows anything about English geography, this is what you would expect. So to sum up, 1 minute over time. You can use substitutes, you can use complements, and you can use bundles, right? That determines how you would do this. This is what you would do. You look at the purchases, you would look at visits, You can apply it to health risks, you can apply it to recreation, and you can apply it to all sorts of amenities around your house. So that's it for this week. Next week we're going to look at stated preference methods, that is interviews and experiments, to derive essentially the same values.